Hi dear, today we will do a problem based on the complex number and it was asked in I.I.T. It is a good one and it will make your concept very clear. Okay, so let me tell about the problem. The problem is let there are two complex numbers z1 and z2. We are given two complex numbers, one is z1, another is z2. If magnitude of z1 is 9 and magnitude of z2 minus 3 minus 4i is 4, we are given the magnitude of the z1 and we are not given the magnitude of z2. Instead, we are given the magnitude of z2 minus of 3 minus 4i, which is 4. And we have to find out, then find the minimum value of magnitude of z1 minus z2. We have to find out the minimum value of magnitude of z1 minus z2. This is our question. Okay, so let me start the solution. It is given that magnitude of the z1, one complex number is z1, its magnitude is given to us 9. And another information that is given to us is that magnitude of z2 minus of 3 minus 4i is 4. We are not given the magnitude of z2. And he is asking what is the minimum value of magnitude of z1 minus z2. He is not asking z1 minus z2. He is asking the minimum value of magnitude of z1 minus z2. That he is asking. Okay. Anyway, we can solve this problem in a tricky way. We will draw the figure. From the figure, we will conclude the result. That is the best way, and that is the only way you can say. If we take z1 equal to x1 plus I by 1 and z2 x2 plus I by 2, then it will be very difficult, in fact impossible, to get a result that the minimum value of z1 minus z2. We won't be able to find the magnitude of z1 minus z2, forget about the minimum and the maximum value. Anyway, what the concept is involved, that I am telling you first. After that, we will proceed. Okay? The concept for solving this problem is very simple and very important concept that we use many times. Suppose we are given an equation like this, magnitude of the z is equal to a. It has a geometrical meaning. What the meaning is? It means that z lies on a circle. Locus of the z is a circle with center 0, 0. Its center is origin. Its center is origin. And radius is a. Radius is a. Just notice that on the right side, a is written. That is the radius and it is the magnitude of z. It has to be positive, one thing, and it will be a real number. Right? And suppose we are given something like this, mod of z minus z naught is equal to a. Then also, locus of the z is a circle. Then z lies on a circle. Z lies on a circle. But its center is z naught, not the origin, not 0, 0. With center z naught, which is a complex number. With center z naught, that is a complex number in the Argand plane. Okay. And its radius is a. And radius of the circle that will be found will be a. This is the concept we are going to use to solve this problem. Okay. And let me start the problem first. It is given that mod of z1 is equal to 9. That means z1 lies on a circle. On a circle with center 0, 0. With center 0, 0 and radius. I am writing radius is small r, that is 9. Okay, we will plot it afterwards. Before that, we will find out the locus of the another z, that is z2. it is given that magnitude of the Z2 minus of 3 minus 4i is equal to 4. Okay, we can write it like this: magnitude of Z2 minus, I will take common, I will write in the bracket 3 plus 4i is equal to 4. Now I can observe that Z2 lies on a circle. I am getting a result that Z2 lies on a circle. With center Z0, which is 3 plus 4i, with center 3 plus 4i. Z0 is 3 plus 4i, and x coordinate of Z0 is 3, y coordinate is 4, you can say. And its radius is equal to 4. Okay, I got these two results. Now I will plot Z1 and Z2. Let's draw the figure first. We have magnitude of Z1 is equal to 9. I am writing it again. And magnitude of Z2 minus 3 plus 4i is equal to 4. Anyway, I will plot a circle with center 0, 0 and radius 9. And Z1 will lie on this circle. See, this is the circle of radius 9, center is somewhere here. Let me draw the x axis and y axis. This is our y axis. And this is our x axis. Okay. And Z1 lies on this circle. Z1 can be here, Z1 can be here, Z1 can be anywhere on this circle, which has a center 0, 0, and its radius is 9. That means this coordinates of this point will be 9, 0, and coordinates of this point will be 0, 9. No need to mention all other points. That is sufficient. And Z1 is lying on this circle. Now I will draw another circle. It is given that magnitude of Z2 minus 3 minus 4i is equal to 4. And the center of this circle is 3, 4i. I will move a distance 3 units here and 4 units in the upward direction here. I will get the center of the another circle of here. The distance of the center of the another circle from the origin is 5. 3 square plus 4 root is 5. And see, the whole distance from the center, as we extend this line up to here, that is 9. Total length is 9. Center of the circle is at a distance 5. That means this distance is left 4. Now I have to draw another circle with radius 4. And the center C, I can say C is here. Okay. If I draw another circle of radius 4, it will touch the x-axis here. And it will touch the larger circle here. It will not intersect, or nor it will lie come inside the circle. It will touch at this point. This point I can say A. So the another circle will touch the larger circle, the blue color circle at the point A, and it has a radius 4. Now I am drawing it. Since we have to take out the result geometrically, so it's better to draw a figure very accurate, like this. Okay, it will intersect the y-axis, but it is in the figure it is not clear. Okay, the horizontal distance would be 4. It is in the figure it is touching, but it will intersect. You can ignore that. Okay. Now Z2 can be anywhere on this circle. Here, 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 anywhere. Z2 can be anywhere. I have to find the minimum value of magnitude of Z1 minus Z2. Now, what is the magnitude of Z1 minus Z2? Let me find out first what the magnitude of Z1 minus Z2. Suppose I take Z1 here and I take Z2 here. Suppose here. So the distance between these 2 points will be magnitude of the Z1 minus Z2. Suppose I take Z1 here and Z2 here. So the distance, this one, will be magnitude of the Z1 minus Z2. So the distance between these 2 points will change according to the points we select Z1 and Z2. And we have to find out the minimum value of magnitude of Z1 minus Z2. not z1 minus z2. Okay, so this length is quite large. This is not the minimum value of z1 minus z2. This length is also very large. This is not the minimum value of z1 minus z2 mod. So if we see carefully in the figure, we will observe that when z1 comes here at the point A and z2 also comes here, I mean to say when z1 and z2 coincides, the distance between them becomes 0, right? So the magnitude of z1 minus z2 becomes 0 when z1 and z2 coincides. z1 and z2 coincides. For any other points, the magnitude of z1 minus z2 will not be 0, it will be larger than 0. So the minimum value of magnitude of z1 minus z2, minimum value is 0. That is our answer. And it is possible when z1 and z2 are coinciding. This is the important thing, when z1 and z2 are coinciding. And z2 are coinciding. So this is the answer we got for the problem that was asked. For that we did nothing. We plotted the graph. We plotted the figure of z1 and z2. From the figure we can see that magnitude of z1 minus z2, or the distance between the 2 points z1 and z2, is minimum when both the circle are touching each other at the point A, and it is 0. Right? Suppose it was asked the maximum value. It was not asked. We can also ask the maximum value of magnitude of z1 and z2. Suppose it is asked, what is the maximum value of z1 minus z2? z1 minus z2 maximum value. Suppose they are. In this figure, if we extend the line OA in the backward direction, suppose I take z1 here and I take z2 at the point A, then the distance between the z1 and z2 will be the maximum. They will be diametrically opposite, and the distance between them will be 9 plus 9, that is 18 units. So z1 minus z2 will have a maximum value, that is 18, when z1 and z2 are diametrically opposite. Right? So what we can say is that z1 minus z2, magnitude of z1 minus z2 is less than or equal to 18, and it is greater than or equal to 0. Minimum value is 0 and maximum value is 18. That also could be asked. Maximum value could also be asked, but it was not asked, so I will not bother further, but I told you. Now let us come to the another problem based on this concept. Okay, but I will do it in short. The another problem is that number of solutions of the equation mod z is equal to 3 and mod of z plus 1 plus I is equal to root 2 is r. We are given 4 options. Right? So no need to tell the theory again. I will do the problem directly. See, we have to find out the number of solutions of these two equations. One equation is magnitude z is equal to 3. That means it is a circle with center 0, 0 and radius 3. I am drawing it. This is a circle with center 0, 0 and radius 3. Okay. The whole distance is radius 3. It is 0, 0. Keep into the mind, this point is 3, 0. And this point is 0, 3. Another circle is magnitude of the z plus 1 plus I. This is also the equation of a circle, as I told you, is equal to root 2. We can write like this: magnitude of the z minus of minus 1 minus I is equal to root 2. This is a circle with center is -1 minus I. X coordinate is -1 and Y coordinate is also -1. And its radius is √2. Okay. Just see. I will get X coordinate -1 here. Y coordinate -1 here. No, Y coordinate is -1 somewhere here. Okay. Minus I is there. So the circle, center of the circle would be somewhere here. Okay. And I will make a little correction in the figure. It is not like looking very good. So figure should look also good also. Anyway. This is a circle. Right? And the distance of the center of the another circle from the origin, this distance is √2. And total distance from this point to this point is 3. Another circle has a radius √2. So it is passing through the origin. The circle will pass through the origin and it will be something like that. It will not intersect the another circle because the radius is √2. Suppose we extend this, it will be √2 again. The distance of this point from the center of the circle will be 2 √2. Diameter, you can say dia of the smaller circle. Dia of smaller circle. Smaller circle is 2 √2. That means 2 into 1.414, that will be 2.82 units. But distance from the origin to the larger circle has a radius 3. So a smaller circle will not intersect the larger circle. It will lie completely inside. That I am saying. Okay. And both the circle are not intersecting at any point. So we can say that there is no solution. No solution of this equation. That is option D is correct. We won't have any solution because both the circle will not intersect. There is no common Z which satisfies both the equation. I hope you have understood the solution and I am stopping now. Thanks for watching.